Okay, so this is the uh, manual testing class that we're going to go through. So, like I said, we're going to go through this using this particular ISTQB ICEP Foundation Guide.
Make apology on behalf of myself.
So, like I said, so we're going to use this book. So, and it's a very good book, and I think it's also simple for you to read. So, it's bulky. It's got almost like 130 something pages. So, but I'll go through them, but I'll be a bit fast. But I'll tell you what you need to read if you're going to go for interviews. What are the parts that you need to focus on, and then so you see that okay, it's not everything that read. I usually start this training by telling people that most of us will do testing. So it's like every one of us will have done one part of testing before now. So whether when you bought a new phone or you're on a web page or even as easy as or as simple as when anytime you wake up every morning, you raise your legs, your arms, and everything. So, and what you need to do is you check them whether they are functioning according to spec. You open your eyes could see, but if you open your eyes one day and you couldn't see at all, then you know there's okay. So I think someone said you couldn't hear me. Okay, 1 minute. Every one of us will have done a bit of testing, whether formally or informally. Informally, in the sense that when you wake up every morning, you make sure your body function as is being specified. So you know your eyes you see. If you open your eyes, you couldn't see. So you either call an ambulance or you call your GP to see what actually is the problem. So technically, in testing, that's what you call you raise a bug because there's a defect in the code. So the same way also you bought a new phone and you know what you're expecting in that particular phone. For instance, let's say you bought a Samsung phone and luckily for you, it was not a Samsung phone that was delivered to you, it was an iPhone. So that's technically a bug. So but what do? You also have to complain to say, oh, I was meant to get a Samsung, but I got an iPhone if you want to report it. But of course, it's a bug because that is not what you were expecting. So the same also if you are lucky enough to get the Samsung, or now you open it and you want to confirm that all the everything that's in the requirements or in the manual is what you are getting. You open the app, you want to be sure that everything works. I don't see most people that will get a new phone today and they'll start making calls. It doesn't normally happen. The first thing you do, you browse around to confirm everything is fine. You don't start using it at a go unless you have an emergency. The first thing you do is to confirm that this is what I'm expecting. And maybe out of excitement, you go through everything. You make sure, okay, I can do Facebook, I can do Twitter, I can do everything, I can browse. So yeah, those are the things that it's called user acceptance testing. So you as a user of that phone or application want to certify or verify that it meets your requirements. So technically, what you are doing at that particular time is testing. So was that a question or a confirmation? Okay, I will continue. Okay, yeah. So what you just done was basically user acceptance testing. So and like I said, most of us will have done that. So with that notion, so I will want to alleviate your fear to say, oh, I haven't have experience in testing or in manual testing. You might have. So you just now need to know how you do your testing. For instance, I do testing professionally. Maybe you do your own informally. But now, how do you now leverage your knowledge of testing as an informal tester with my own as a professional tester? So what is the difference? How do I do my own testing? how do you do your own testing? So that's the point of this particular training. So I'll go through. I hope everyone also can see my screen. So I'll start from chapter 1 of the book. So I don't need to waste time on this one. So yeah, basically about the book. So fundamentals of testing. Okay. So the reason why software fails. So we got different issues why software fails. We have different. I think one of the big one was like Apollo, the U.S. Apollo. What's it called? Rocket that was launched. Also, the first launch of European space. Area 5. So you have different failures of systems that were failed. So, but what actually was the problem? But they will actually be attributed to bug in the system or defect in the system that make them to fail. So you can see the importance of having a software tester to properly test this application, so that because when application fails, it costs money to fix. Sometimes it can even cost life. It can even cost the whole company to crash down. So you can see the importance of this. So now there are 3 things that you need to know very well, which I think is very, very important. So if you go for an interview and when you mention things, you need to know what they mean. So what's the difference between an error? What's the difference between a defect and a failure? So error is a human error, as in what genuinely or what you put in there as an human error. So like you write a code, you went on a break, and then also your keyboard type A instead of typing B. So that is error. So then that error, if it's not discovered early within the code, so and it goes into the system and everything before then it goes to the QA to test. So it becomes a defect when a QA actually been found that particular defect. So a defect also it's what is called a bug. So like I said, error is like a human mistake. So, but if that error is not rectified or is not corrected, it could lead to a defect because it's been handed over to another person to test. So when the person tested it, what he found is going to be a defect. So, but now that is still within the system. So, but if the defect is not even found also, and it goes live, so at that particular time, what happened to the system? The system failed, it crashed, or the user are not able to use it. So it becomes a failure. So you can see how a mistake or an error will develop into a defect or a bug. And if that bug is not found, it goes to make the system to fail. So becoming a system failure. So you can see if you are talking at interview, you need to know what are the differences of this thing. So you are not mentioning error when you mean a bug or defect. You are not saying a failure when you actually mean a defect. So you need to know what this the differences between this. So okay. So I think these are okay. 1 minute. Okay. So one thing about testing is exhaustive testing. They say it's not possible, so to say. So you cannot say, oh, I've tested this application exhaustively. So you cannot also say, okay, oh, I've covered everything. Everything is tested. Everything is, you are sure that nothing it could go wrong. In testing, it's just a fallacy. You can't actually say that. So you can only say you covered the requirements, you cover what you need to do, you've run your test. But you cannot actually say, oh, even whether simple or complex application, exhaustive testing is not possible. So that's basically what it's talking about. Testing and risk. So testing and risks, in most cases, people prefer that you undo testing with risk, because you need to know if you are testing a game application, you need to know what are the risks attached to it. It's like, okay, it's game and it's nothing, no one is going to lose their life or their money. But it's different when you are testing a bank application where any mistake or error that's not discovered leading to defect or any failure could mean that the bank can lose money. Or if you are testing a medical application, it's not about even losing money now. People can lose their life for that particular. So you need to know what are the risks attached to the application that you are testing. And I don't know. I might say the higher the risks, the higher the money that you're going to be paid for for the job, actually. So it's like if you are working in a bank, because it's got higher risk. So unlike if you are working in I don't know, so in a lower risk application. So, and if you happen to work in airlines, that you have to test the airplanes and everything. So I think the risk is higher in that regard. So testing and quality. So in most cases, for you to test a feature, you need to know what are the parameters you need to look into. So you have your time. So because everything has to be time bound, also the quality and the money, everything together, you need to know what are the things that is in. For you to increase the quality of our application, you need time and you need money. So you need to know how to address those together for you to deliver the system faster. So it's basically, some people can test the same application for maybe 3 months, where it only take 1 month to do. So I think that's the point of this particular test, even training, also to see when you have one month to test an application, what do you do? How do you address it? And also, if you have 3 months to test the same application, what are the things that you need to do? What are the techniques that you need to use, so that you can be able to say you covered most of your test cases and you have systematic coverage. So when do I decide if enough is enough? To be honest, this is one of those interview questions to ask you. When do you stop testing? So, and when do you stop testing? I would say most often than not, there's a criteria that has been set even before you start testing. It is called exit and entry criteria. Before you start testing, there should be an entry criteria that should be met before you start testing. Also, there should be an exit criteria, which is on something they call the completion criteria, that should be met. So before you can actually say you finish your testing. So once those ones are met, then you can actually say enough is enough. But you cannot actually say, oh yeah, I've done exhaustive testing, so yeah, there's no bug in this thing. So those are fallacies. So testing and debugging, yeah. So I think I mentioned this also before now. So testing and debugging are different activities, actually. So debugging is a process that developers go through to identify the cause of a bug. Testers don't debug. Testers don't debug. So what you do is you retest a code that has been fixed. You retest it and you do regression testing on that particular application. So testing is not debugging. So testing is to verify or ascertain that the code meets the requirements. And the most important point of testing is to improve the quality of the application. So, and it's not same thing as debugging. So static testing and dynamic testing. So I think quickly, static testing, most of us will have done static testing. So it starts from the fact that you are doing your thesis, you are doing your project, and you've written a requirement, and you want me to review those requirements, and it's written in English, it's in paper, it's not code. So, and that particular verification is called static testing. So basically, you are not running the application, you are only verifying a static view as you are doing a review. basically, why do you need to do a review? You do a review of the requirements to prevent defects, because once you're able to establish that there's a defect in the requirement or in the spec, it's easier to fix. You just need to get backspace, delete, to cancel down that in there. But dynamic testing, it's kind of, you have to execute that program. You have to execute a program, and also then you have to have some test data and you put them in there. So the difference is, like, in static testing, you don't do any execution at all. But in dynamic testing, you have to execute that particular application. Static testing will basically be able to find human errors because, like I said, it's not. It has not yet been migrated. It has not been. It has not been past the execution stage. So because it's not executed, so what you're going to see was basically like kind of human error, mistakes, and everything in documents such as requirements. So, but during dynamic testing, you find genuine bugs because then you are actually executing the test. Testing is a process. Yeah, it's got its own steps. That I'll say this is what will separate even informal testing with formal testing. When you, like I said before, I said it's possible that you bought a phone. When you bought a phone, what happened is, like, you start to do your user acceptance testing, but you don't follow any process at all. So, for it's different when you are at work. You have to follow a process, and what are these processes that you need to follow? So we'll go through them in great details in this particular training. So, and also in testing, there's a set of techniques that you have to follow. So I mentioned this before. It's like, even if you have 1 hour to do your testing, what are the techniques that you need to follow? If you have 2 hours, if you have even 2 months to do your testing, what are the techniques that you need to follow? So, and depending on which type of application you are testing, and also which in terms of you need to have these techniques to use, and also it also depends on the application itself, the data that you want to supply to the application. So, but you need to know what are the techniques to use at every particular time. So, and also for the application that you are testing. So it's not going to be the techniques that you are going to use are not going to be the same for every application. So, but you need to know what techniques actually suit the application you are testing, and also what techniques that you use to generate the data itself. So, principles of testing, general principles of testing. So like I said, testing shows the presence of a bug. It doesn't show the absence of bugs. Testing shows the presence of bugs. It doesn't show the absence of it. So you cannot finish your testing and say there's no bug in the code, or the software is error-free. It is not possible. You don't say that. You can only say that, okay, I've done my testing and I found 5 bugs or 3 bugs, or I didn't find any. But you cannot say that, oh, I have been able to achieve my objective, and I can say there's no bug in this software. It is not possible. You don't say that. So you can only say based on the knowledge or what you know about the presence of bug, not the absence of bug. And I said this also, exhaustive testing is impossible. You cannot say, oh, I've been able to test it thoroughly, and I can actually say there's no more testing, or there's no permutation of testing that needs to be done. So, early testing, I think these are under interview questions. They ask you that when do you start testing? So that's the thing, when do you start testing? I think the answer is testing should start as soon as possible. What is as soon as possible? As soon as there is notion to start the project. When they are bringing the teams together, tester also should be brought. So because we mentioned about static testing also, which is very, very cheap. Static testing is basically testing the requirements itself, or testing the document that is going to be used to develop the application. So if a tester is brought in as early as possible, even before you start to develop the application, they can actually test that document. And when there's a bug in that document, it's easy to fix, because what you need to do is to go into the document, change it. So it's cheaper than when you now find a bug in the application that you have to go and fix it, as developers to fix it. So the simple answer is that testing should start as soon as possible. You shouldn't wait until the application is ready or developed. So that is that. So yeah, this is a good example on the comparative cost for correcting errors. So if you find any error in a requirement, it costs only £1 to fix, or $1. So if it's during the coding, it increases, and exponentially that increases when you now find it in life. So you can see it's kind of $100,000 so for it to be fixed. So you can see the importance of finding bugs as early as possible. So that's then also defect clustering. So of course, as a tester, there's a notion to know that, okay, there's always to be problem in software. That's where you are there to test. And also, it's possible that this bug or problem or errors sometimes cluster at one particular place. So you need to know, like I told you, that if you are given 1 hour to test an application that should take 1 month, you should be able to finish it within 1 hour. But what are the techniques that you need to know? So this is one of those techniques. You need to know what are the clustered areas that are prone to bugs. So you first attack those ones. So, and you need to know, okay, what are the reasons for the bugs to cluster in that area? Is maybe because the system is so complex at that area, or the code is volatile at that area, or it's every time things change in that particular area of code, or maybe because of the experience of the staff or their inexperience also. Like Pareto principle, 20% of the bug that you find is going to exist in the 80% of the area. So it's basically like that. So it's basically like 20% to 80%. So most often than not, 20% of the bug or 80% of the bug that you're going to find may be in the 20% of the module. So what it means that you will see that when you are raising some bugs, they are all common in a particular module. So if you have 10 bugs, maybe 8 of them will be for one particular module, while the remaining 2 are only for a few other modules that you tested. So you need to know which one is the problematic one, and then you can focus on them very well. So, and pesticide paradox. So this actually is like, for instance, I think as a new tester or an informal tester, this is another problem that you're going to find. So you got an application, like for instance, let's say we have an application that accepts numbers 1 to, let's say, even numbers 1 to 10. So most people, if you have to test that application, you want to test an application that accepts even numbers from 1 to 10. What most people would do is say, okay, I'll give it 2, 4, 6, and 8, and 10. So doing that, you are testing the same set of sequence. You are not doing different tests. So because what you in that regard, you've only done one test, because all of them are the same set of tests, because you are only supplying even number. The same way 2 will be addressed is the same way even 4 and 6 and 8 and 10. So you've not done things separately. So in that regard, only one test is sufficient for what you have done. So that's what is called pesticide paradox. So you continue to do the same thing, the same test of tests, and expecting to find a new defect. It's not going to. It's not possible. So, but how do you know that you are not you are not doing the same test? So it's basically on the test techniques that you are going to use. So we're going to follow also talk about those ones also. What are the techniques that you need to use? How do you establish that you are not testing the same test every time? Of course, testing is content dependent, so you should not take a website and start testing without knowing what exactly is the context. You need to understand what you are testing, and also you need to understand the context that you are testing it. So, and I also mentioned that absence of error is a fallacy. You can actually, oh, that particular bug or that application has not got any error at all. So you can only say, oh, you found some bugs. You can only validate the presence of a bug, not the absence of it. So now we come back about the process. When you are testing an application, what are the process that you follow? So it's different from when you are like an informal tester. You got your application in front of you, you dive into it, you start testing. But that's not what you do professionally. The first thing you do your planning, you do your test planning. So in your test planning, I'll go through what you need to do. So also from that, you move to your test analysis and design. You create your test cases, design your test cases, you design your data. So, and in those ones also, you need to do those ones. So from there, you move to test implementation and execution. But what happened? This step is what an informal tester will go through at the same time, and say, yes, you start implementation and execution. But you don't go through the test planning and control. You don't go through the test analysis and design. So that's what actually separates the informal tester and the professional tester, because you go through the rigorous planning and also test analysis and design. Then after that, you evaluate your exit criteria and also you do reporting. I mentioned before now, I said one of the questions they ask you at the interview is, when do you stop testing? You can see now, it's like when you evaluate your exit criteria, so and you think that it has met what is being stated, then you know that, okay, you are close to the test closure. So, and you know that, okay, yeah, I'm about to finish my testing. Then you start your test closure activities. What are the things that you need to do to round up your testing, the environment that you want to return to the state it was before? So those are the things that you need to do in there. So like I've seen, you can see now, at this point, when you have your evaluations of the exit criteria, if your exit criteria is not met, you go back to the test analysis and design, and you continue that cycle over there. So that is that. So all these are kind of theory. So I think if you read them, you should be able to understand what each step or each process entails. So I will not bore you with those ones. So and yeah, this is the part I would say you should read very well. Also evaluating exit criteria. So because that's another thing at the interview, they ask you, how do you evaluate your exit criteria? How do you know that you finish your testing? So you can say checking whether the previous predetermined exit criteria has been met. So and determine if more tests is needed and if specific exit criteria need amending. So then your test closure activities, what do you need to do when you're actually closing your test? So is your documentation in order? Is your test environment archived or need to be archived? Your test infrastructure, are they returned back to where it was before? Then what do you need to pass to the maintenance team? And also maybe you need to write your lesson length. So everything has to be written in your test closure, has to be included in your test closure activities. So that is that on that one. I'm not going to go through those ones. Ethic of code. So okay. So that takes us to the end of that any question before I go into life cycle? Any question? Let's go through software development module. So if you want to develop a software, what are the simple development module that is followed? There are different software development modules. So, but the first one, which is the traditional one, which is still used in the market, but it's not kind of favored one, I would say, in my own opinion, it's the waterfall module. So, how do I remember this? It's just waterfall. You just you just go into the water and then that's it. So, the first thing you do, you gather your requirements. So, your functional requirement is also gathered. Your technical requirement is also gathered. So then also program requirement or specification is put together. So then after that, you do your coding and you do your testing. So, and that is the waterfall model. So the bigger issue on this one is like when you, so the biggest issue is like, so now at this point, you have your requirements specification already done. It moves to functional specification, it moves to technical specification and program specification before you start coding. So the problem is like, even before you start coding, these steps has to be done, right? So if in the process that the person start coding and he found out the requirement is wrong, they have to go through that step again. But out of if even the defect is found during testing. So if you found during testing, you have to go through the requirement. So it means that if you have an application to do, like let's say a big website or an app, so you have to do your requirement specification for the whole application. It has to be finished before you move to functional specification. That has to be finished. This can take months, and this can also take another month or two. This can take another 3 months or two. So before you even start testing. So even testing will sometimes might wait for 6 months before you actually see anything at all in what he's testing. So then when you see the first thing, maybe you see a bug, then you have to go through the step again. So which is not kind of ideal. So that's one of the disadvantage of waterfall. So another one is the V module. So V module has got, I think it's so to say a bit similar, but it's a bit is better in the sense that you now have each level of testing attached to each of the steps or the process. At the requirement specification, you have acceptance test plan written for it, and also at the functional specification, you have your system testing done at that level. Then also at technical specification, you have your integration testing is done. Then at the program specification, you have your unit testing done. So and also of course the coding. So at every level, you have each corresponding testing that needs to happen at that level. So it's not like you wait on the end and you start to do your testing. So when the requirement is done, you have your acceptance testing for that level. So it goes there, but it's still the same thing anyway, because it goes down and then it goes up again to that level. But the only thing is like now at the unit testing, you use your program specification. At your integration testing, you use your technical document, and at the system testing, you use your functional specification. Then at user acceptance testing, you use your requirement testing. But to be honest, it's still the same. It's still the family of waterfall module. So now this is one of the, in my opinion, this is a favored one. So an iterative development, which is also called agile. So everything is done in iteration. So you enter with a requirement. So and after that, you do your design, you do your code, you test. So this is if you have like, let's say a big website to do. So you break them down into different iterations. So which could mean that you take the home page on its own self, you write the requirement for the home page, you design the home page, and you write the code for the home page, and you test the home page. So on his own self, right? And it does happen agile. Most of them you have your sprints, maybe it's 2 week sprint or 3 week. I've seen some people with 3 week sprint or 4 week sprint, but the most common one is 2 weeks, 2 week sprint. So when you finish your home page, maybe you go to your login page. Also, you do the same thing. You write your requirement for your login page. You design the login page. You write the code for the login page, and you test the login page. Then you move on again to maybe for the login page, you've done registration also the same way. Also, you do requirement for registration, design, code, and test that. So you go into iteration like that until the whole website is done. So unlike the other one, you have to do the requirement for the whole web page. You do the whole web page. Unlike I said, the waterfall one. So the requirements has to be finished. You write requirement for the login page, registration page. You have requirement for the home page. You have requirement for maybe posting. Everything has to be done before you move to design. So then after design is done, you move to the coding for every page. Then the tester also now has to do everything. So at that point, this tester will serve like a policeman, starting to say, okay, this is going to go to release or it's not going to go to release. So that's what you are going to do, because you're kind of the last person to release. So if you say it's not going to the release, at this point it was waiting for the release. So then if you say it's not going to go, you have to go through requirement again, design, and so that's on the waterfall part. But on the iterative development, which is on the agile one, so you do them in instrumentals, so that even when the whole page is finished, you move to another one, which is a registration page. When the registration is finished, you move to the login page. So on and on like that, you have something that is even, and also the users are going to see a bit of the system as early as possible. They are not going to be waiting for months to actually have a glimpse of what the development is doing. So which is also very good. It's improve feedback and also communication among the team. So that's what I can say in that. Okay, test level. So like we said also, I've mentioned about testing as soon as possible. So now we need to go through the characteristics of good testing. So across the development lifecycle, this is not dependent on vModule or Agile, but what are the things that you need to consider? What are the components that you need in testing? So the first one is the level of testing that needs to be done at every particular time. Whether you are using Agile or you are using vModule or you are using Waterfall, you need to have a unit testing done. I tell people, according to ICEP, right, unit testing is done by developers. But this time around, there's a paradigm shift in how things are worked now. So even the unit testing now is now being done by some testers right now. But technically, it should be developer that is doing unit testing, because they wrote the code, they need to test it. But in some industry, you see, tester now assisting in the unit testing, because that's another paradigm shift. So everyone now works together. And in Agile, I think maybe later we talk about how Agile works. There's no concept of testers in Agile. Everyone is a developer. So even though you have a functional role as a keyway, but you are also a developer technically. So, but like I said, okay, going back to what we are focusing right now, level of testing. You have unit testing done. So after unit testing, there's integration testing. So, and also there's system testing, and also there's acceptance testing. So, and I'll go through them one after the other. So, like I said, unit testing is the component testing. So it is done by developer. they write the code, they test it. So, and then after that, they put it to every code they write has to be unit tested. So I would say so. And the approach today is basically on the TDD approach that we are also focusing on our training in the other parts. So then integration testing. So everything coupled together. So it's now called integration. So after that, you couple everything together. You test the interface between the two system or components that has been chipped together. So a good example is you have two applications or you have two programs being handed over by developers. So you do the integration between those two, that the workflows, the actual architects and everything. So how the code interface with each other, database and also system. So you do your integration testing. So there are two different approaches to this. I think you don't need to worry about that. So it's how you do integration, big bang or top down. Big bang, put everything together, bang, and you put the switch on to see if it's going to explode or not. So, but there's also top down that you build from stage from top stage to the other. So that is, so I'll go system testing. This is the most popular one that most of us will follow. So it's like the system is being coupled together. So and we have it now. So but now this is where most of the tester will be in. So you have your functional requirements and you now have your system be handed over to you. So then off you go. You start to do your testing from there. So and then after that you have acceptance testing. When you finish it, you move into another level of acceptance testing. So which is also called user acceptance testing. It goes to a user representative or maybe also like a business analyst or someone even from a third-party system, third-party company to verify if that system actually meets what the user are looking for. So that is the acceptance testing. So and there are different ways to do that. You have alpha testing and beta testing. So that is that. So also testing types. So I think you might have heard about this. There's functional testing, there's non-functional testing, structural testing and everything. So functional testing is based, as the name implies, is based on the requirements and also on the functionality of the systems. So and how the system should perform or operate. So and that's what you need to test. Non-functional testing, that you want to test those usability part of the system, how the system perform under loads. You want to do stress testing. So and some people also will classify security testing on this one also. So I don't want to waste time on this. So maintenance testing. So yeah. So that I know I've speed past most of these things. So static testing, I don't want to waste a lot of time. Is basically reviews. So reviews your code or review your requirements. So it's not. I don't think you're going to be hired to do that, to be honest. So, but it's good to look at the requirements, check the requirements, check it meets what the user wants, and there are different techniques that are used, and also the process also. So I think I would say, okay, if you read through, it's not something that you go for an interview and they ask you what are the process or stages of formal review. You won't even get that, to be honest. So I wouldn't worry too much on that. So in this little time that we have, so yeah, formal, informal review, walkthrough, or technicals, I don't that. So I think chapter 4 is the most important part that I used to focus more to people, which is I think is the test. Yeah. So this is a big one actually. As a tester, this is what you want to focus on. So if you want to read any particular chapter in this book, I would say this is it. This is it. So it's your test techniques, and I'll quickly go through that. I'm not sure if I'm able to finish that. So then, anytime I read this, I remember a friend of mine. What is a test condition? Yeah, a test condition is the item or event of a component that could be verified. So it technically means that what that thing that you are testing, the function that you are testing, or the feature that you are testing, that's your test condition. So you need to understand what this means. So if you're going for interview, you need to be able to say that terminology as it is. So you don't actually go about and mentioning or using a layman language in interviews. So test conditions are features or functions that you are testing or you are verifying using one or more test cases. Then, okay, what is test cases? Test cases are your set of input, preconditions, or expected results, or post condition that you use to certify your test condition. So it's kind of interwoven together. For you to test a test condition, right, you need your test case. So what's your test cases? Your test cases are those inputs. What, for instance, like when you have your new iPhone 7 or iPhone 8 or iPhone X. So what are your test cases? Your test cases is what you're going to input in. You're going to do your actions or what you are expecting the iPhone X to do for you. Those are your test cases. So, but what are your test conditions? Oh, I want to test that, okay, it's a blue screen. That's your test condition. Or I want to test that, oh, it is an iPhone. That's your test condition. I want to test that, okay, I can log in to Yahoo. That's your test condition. So those are the features that you are testing. But how do you test it? The step that you use to test it, the data that you use to test it, those are your test cases. So I hope I'm able to explain this in a layman language to you. So it's very, very important to get this so that when you go for interview, you are talking about test condition and you know what that means. And also you are talking about test cases, you know what we are talking about there. So, yeah, so these are different examples. So then also idea of test coverage. So this is the thing. So like I said, we said exhaustive testing is not possible. You cannot say, oh, I've covered everything and okay, I cannot say there's no bug. But you, however, because then people are going to say, then how do I know that I am also doing testing? What are the metrics that for me to know that, okay, I've done something? There are different metrics that you use that are quantitative. So one of them is statement coverage, decision coverage. You can actually say, oh, or even requirement coverage. So you can measure what you've done based on percentage or what has been required. So like saying, I've tested 80% of the requirements, or I've tested 70% of the decision. That is the metrics that you're going to push to your test manager. But not like, oh, I finished my testing, but that's not kind of professional. But you want to say, you want to have a metrics of your coverage. That's what you have to say. So, and also, even when you are doing estimation, that also is also good to in that regard, because you know I've got like 10 tests to do, and each one of them is going to take me 1 hour. So you know that it's going to be 1 times 10 that hours that you have to use. So that metrics also we're going to go through later, but not in this particular session. Category of test cases. Wow. Okay. So okay, there's specification based, which is called black box. Black box because it's so black, you cannot see what is inside. So, and it's based on specification. As you know, specification is just documents. So it's called black box because you cannot see into the code. What you have is just the specification. What you have is just that document. It doesn't say anything about the code. There's other one that is called white box. White box because it's so white, you can see inside, and it's also called structural based techniques because at that particular time you are testing based on the internal structure of the code. So this is based on the requirement, and then also that is why it's called structure specification based technique. So, but what are the techniques that you use in this case? You have equivalent partitioning, and boundary value analysis, decision table, and state transition testing, use case testing. I will quickly go through two of them, which I think if you are going for interview, know very well that you know the equivalence partitioning and boundary value analysis. I tell people that this thing, it's very good for you to know how it works, because then you can actually say at an interview that you know this and you've used it, and you can actually give a sample how that works. So those two, the first two, are very, very important. I will emphasize on that. Equivalent partitioning. I tell people about this, that everything, virtually everything, in my opinion, can be divided into two, as in right, wrong, input, output, male, female, even L. Just name it. So negative, positive. So everything that you want to test, everything in life, everything will have left and right, even like that. So there's no, it's sometimes technically impossible to sit on the fence. So, and that's what it's basically about, equivalent partitioning. So you can actually partition your inputs into two, to say negative and positive testing. So, and this is very, very useful when you have numerical data. So, and you, even if you don't have numerical data in terms of other ones that, or you have an application that accepts sex, it can, okay, in this era, maybe, I don't know what's going to happen in future, you have male and female. So that's what you have. So I don't know, yeah, things can change in future. But yeah, the same way also, you have numbers, negative numbers, positive numbers. So the techniques here is for you to divide your test cases into two, split them into two, and put them into, can you actually put them into partition? You have an application that accepts even number. So your partition is like even and odd. So when you are testing, even though it accepts even number, you test one of even number and you test one of odd number. What you've just done is you've done negative and positive testing. So that's another two partition, isn't it? Because it's supposed to accept even number, and you've given one even number, which is the positive testing. And as well, you've done one odd number, which is the negative testing, because the application should not accept odd numbers. So you don't test application by only things that it accepts. You also make sure that it doesn't perform what it should not perform. So if you test an application based on what it should do only, you are only focusing on the positive testing. So as you are doing the positive part, you need to do the negative part also. You should verify that the application does not do what it should not do. So that is a negative testing. So you divide them into two parts and you are able to see that. So, and a good example is this one. Now you have integer ranging from 100 to 999. So what are your valid partition? Your valid partition is anything that falls into that range, and you now have non-valid partition, anything below and anything above 999. So you now have, then also you can now say, okay, yeah, those are one. So how about decimal numbers? What about non-numeric numbers? So you can as well partition your test into two based on your grouping. So your valid and your non-valid. So, and the same way also you could also do for output also. So another example is name up to 20 characters, alphabetic characters. So what's your valid partition? String up to 20 characters. Those are the one you want to test. Then also, what are the negative testing? String more than 20 characters. So, and that is it. Or string containing non-alphabet character like alphanumeric, because it should only accept 20 alphabetic characters. So what about numbers? 20 numbers or something like that. So that should fall into the non-valid partition. So you can see that the same way for your output also is the same notion. So you can partition your test cases into two. So, and that is very point that you need to say at the interview, that you use this method, you use these techniques, because it's also important that you only don't test based on positive part, you also test the negative part, and you give a sample in different scenarios or how you've done that. Then boundary value analysis. If we go up before now, I think we talked about the clustering mechanism, because we said some tests also cluster at a particular place, and this is another technique also, because when developers are writing their code, right, and for instance, you say you have an application that accepts number from 1 to 10. So this will happen when developers are writing this code. They say, oh, for I is equal to 1 or to 10. So you are trying to measure 1 to 10. The same thing happens in counting, right? Even let's say for kids. So say, okay, can you count 1 to 10? And they are counting from their finger, 1, 2, 3. It's possible. What's going to happen? It is that you don't count from 1, or you count from 2, or you count to 9, you don't count to 10, or you forgot to that, oh, I'm now on 10, and you pass, you go to 11. Change here to the bus. So you go to 11. So this is what happens. So, and in that regard, you want to use the boundary value, because you want to test everything at the boundary, right? For you to do that, you need to say, okay, this application accepts 1 to 10. So what you are going to do is, like, you're going to take 1 as a boundary, and you want to take 2 also, to say it's possible that this person is considering 1, but it's not considering 2, because 2 is after the boundary. And the same way, you can also see, okay, what if is 0 also? So at every boundary, you take 3 values. 3 values. In the case of 1, you take 0, you take 1, and you take 2. So because most of them could behave differently. For instance, 0 is invalid. You shouldn't accept it. 1 is at the boundary, and you should accept 1. And you want to confirm that even though he accepts 1, is he going to accept 2, which is also immediately after the boundary. So that is the boundary value analysis. The same thing also with 10, which is the upper limit. You want to establish that, is he going to accept 9, is he going to accept 10, or is he going to reject 11? So at every boundary, you have 3 values that you are going to test. So for you to test this application, you're going to need 6 data. 1 is 0, another one is 1, then 2, and 9, 10, and 11. What you're going to establish is that if you put 0, you should reject it. If you put 1, you should accept 1, and you should accept 2. Then you put 9 also. You should accept 9, you should accept 10, but you should reject 11. So that's how to do that, using that mechanism. So it's not, because it's easy for other people to say, okay, supply 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's not it, right? In this approach, by using boundary value analysis, you only need 6. But if you use equivalent partitioning, you're only going to need 2. Because you only need valid one and invalid one. So that means if you put 1, that's okay, and 0, that's fine for equivalent partitioning. But for boundary value, you're going to need more than that. So you need to know when to use it and how it's being used. But if you have a data around the boundary, then boundary value analysis is the best approach. So for you to use. So I'll say that is basically it for today. Decision table, to be honest, I don't think we need to cover that for now. So so if you have any questions, so let's just quickly discuss that.